Back, and I was hoping to see everybody had gone out and gotten a green T-shirt or something, given that we were now we know this is Friday, right? So that was not one of the things that David and I were prompt. We got a lot of prompts, but we didn't get all the rest of that. Okay.
I'm with you, so.
You're with us, okay. Yes, okay. Now, that's right. That's right. There's some acknowledgement. So you've just had lunch. We have about 20 minutes before the carbohydrates kick in, right? And so you need to be doing more things as we go forward. So let me do this. I've got until 2:30. So we're going to take a break at 2:30, okay? And your task is to make sure that I stop at 2:30, all right? Fair enough? Yeah. All right. Let's start with a big question. So part of what I'm going to do is in the next 10 minutes, I'm going to link together all the questions that I got at lunch. Different people had different questions, really good ideas. The main thing I want to do between now and 2:30 is I want to present the criteria for doing visual analysis in single case methods. And I don't want you just to be able to describe that. I actually want you to be able to do it. And I want to give you a website that you will spend all of tonight working on and going through and testing your single case skills. This is Friday night. What else are you going to do, right? I mean, get a beer, sit down, look at graphs. What could be better? But a couple of things that just to be really clear. We're going to be talking about multiple ways of interpreting single case methods. And one of the questions was, well, are we talking that there's either visual analysis or statistical models? And the answer is no, that's not the case. I'm going to make the argument that if you're doing good analysis of single case methods, one, you always start with visual analysis. I'm going to argue that you always start by doing visual analysis. In truth, that's also the case with most of group design research. One of the first things you do when you do group design research is you plot your data and you take a look at it. Then you go back and you start asking questions more systematically. The next question is, well, what kind of statistical methods do we need to use? The honest truth is we're still waiting for David to tell us the Holy Grail, but what he's showing us is that there are lots of options. So the non-overlap, of the non-overlap strategies, the one that we find most palatable is tau u with corrected trend. So of the ones that you looked at, it is perfectly okay with us to calculate the extent to which a single case study, the whole study, is effective using tau u. We are not impressed with any of the other non-overlap methods. Now the reason that I put it that way, the reason why you are going to want to become knowledgeable about statistical methods for interpreting single case designs is threefold. Thing number one, as a scholar, I want you to define not individual studies, but practices that are evidence-based. Evidence-based practices will always require synthesis of multiple studies. There will never be, I can define this as a practice because I did this study by myself. You need replication, and you need replication by your peers. So the first reason that you want statistical analysis is part of what we're learning is functional syntheses of multiple studies require that you have a way of equating studies. And effect size measures are going to come closest in terms of looking at that. A second reason is we want you to get funding from foundations and the federal government. Basically, one of the messages I will give you, if you are submitting a grant right now that includes single case methods as part of what you're doing, you need to include a statistical model of effect size as part of what you're going to be proposing if you anticipate that your grant would be funded. Third, if you run research and you want the research to be published in an increasing number of journals, publication of single case research assumes at least some additional summary of the data related to statistical models. And the thing that we saw a lot of most recently in the behavior analytic journals was the use of PND, of percent of non-overlapping data. Essentially, that's no longer something that's going to be sufficient. Most journals are now getting to the point where they do not consider that a helpful message. They are looking for alternative ways of interpreting data beyond visual analysis. So, to the extent you want to be a scholar contributing to the field, to the extent that you want to get funded, and to the extent that you want to publish, I want you to build the capacity to be able to interpret single case methods more comprehensively. Second, this is not a religion, all right? This is not, do you believe in visual analysis or do you believe in statistical models? This is all about science. This is, to what extent can you describe something that has credible scientific foundation? And part of what you need is you need to be able to work both with your left hand and your right hand. You need to be able to chew gum and walk. You need to be able to do visual analysis and be able to interpret data. Now, the problem, and I think, come on, you've got to have taken away from what David did this morning, it's not as simple as you might think. I mean, come on. How tough can this be? Can't we calculate the mean of baseline and the mean of treatment? You know, divide by the standard deviation. You can even do common standard deviation. We can do that. Turns out, it's not that simple. All right, so it's going to be a little more tricky than we thought. But let me give you a little place to start. The good news is we know a lot and we've got a point where we can get you beyond there's just a problem. The bad side is, come on, you are at the point of an early development in a scientific field. And in early development in any scientific field, here's what happens. People come up with lots and lots of different ways of doing something, and then over time, they decrease down to the ways that are most effective and most efficient. You are at the point where, as a field, we're trying to come together. Each of us have the direction that we think the world ought to go, right? And it certainly seems great from our perspective. But part of what you want to do is take all of this with a grain of salt. And you want to say, well, wait a minute, how does James Rindskopf think? What does he think we ought to do? And then you think, what does Larry Hedges think we ought to do? And then you think, you know, what does somebody else think? And you, go to Texas A&M and ask Richard Parker. There are very clever people who are working on all of these issues. The point is, don't get frustrated with the fact that there isn't a perfect solution right now. Become part of the solution finding. The point of today is not to give you just the absolute answer. The point of today is to bring you into the point of being part of the solution. Make sense? All right. So that's that part. Now, my job between now and 2:30, remember we talked about what the design features look like? And you're all feeling pretty smart about design, right? We can do the design. Okay, so now the tricky part is to say, do you have the skills to actually interpret the evidence? So does a study actually document experimental effects? So we're going to say either strong, moderate, or what the feds said was no evidence. There's never no evidence. We're going to say insufficient. Strong, moderate, or insufficient. So for a single case study to demonstrate a strong demonstration of effect, one, you need a baseline. The baseline needs to be consistent with the research question, and it needs to define the problem under study. So if you're really concerned about literacy skills of young children, and you build a baseline with 5 children who are at 112% of standard in their oral reading fluency, you have not demonstrated a problem. They're doing great. If you've demonstrated kids who are, well, low in their oral reading fluency, below what would be expected of typical kids, then you've demonstrated the problem. So part of what you're doing is you're demonstrating the problem. The other thing, and this is where I'm going to really ask those of you who are more statistically knowledgeable, I'm going to use normal human words, and I want you to transform them into statistical models. I'm going to talk about a predictable pattern. I want to talk about a predictable pattern, and I want you to start thinking about how, right, Peter, I want you to tell me how you're going to make the predictable pattern an algorithm, so that it becomes not just something that we say, it actually is something that collectively, right, we can have the Academy group hug, and we can say what it looks like. All right, so I want you to look at there, and I want you to look at the data that make up a pattern. We're saying, look, in general, you need a minimum of 5 data points, but they have to be 5 data points that actually demonstrate a pattern. The other thing we're going to say is each phase needs to have enough data to demonstrate a pattern. So it's not just the baseline. The baseline needs to have a pattern, and the pattern needs to document a social problem. Each phase needs to have at least 5 data points. So those 5 data points are necessary so that we can at least begin to get some assessment of the pattern. Then what we're going to do is we're going to look at the basic effect. And so this is a word that you actually have now. We're making this up, right? A basic effect. A basic effect means you have 2 phases. The data in the second phase would not be predicted from the pattern demonstrated from the first phase. So there are 2 phases. And between the 2 phases, the independent variable has been manipulated. The data from the second phase would not be predicted from the data in the first phase. Now, those of you who love to talk about distributions, you would say the distribution of scores in the first phase creates a pattern, and we would expect the data in the second phase to not come from that distribution. That's sort of correct, but not quite. Same basic idea. So hold that idea, and let's go forward. You're always, in this case, talking about adjacent phases. So a manipulation of the independent variable produces change in the dependent variable. And we're looking to see that happen a minimum of 3 times, each at a different point in time. Now, again, relying on the fact that you already know about threats to internal validity. You know that at any point in time, there are events in the community, there are changes in weather, we just saw that today, there are sicknesses that come through, there are the one kid in class who creates all sorts of havoc is gone, right? So you have these independent events that happen that are historical events. You want to control for that. And in group designs, we control for all of life's problems with, random selection, right? We randomize things, and we say, well, there's error variance out there, but we're just going to distribute it in ways that nobody could predict. Here, we're going to do something different. We're going to say, we're going to hold everything we can possibly think of constant, and just change 1. Well, but you can't hold time constant. Time marches on. So what we're going to say is, here's what we're going to do. Instead of randomly doing it, we're going to have at least 3 points in time. If we can predict an unlikely event at each of those points in time, how impressive is that? How much do you need to get to? All right. The other thing that is not talked about enough is that there are also not demonstrations of a competing or alternative explanation. So if you have a competing alternative, that decreases the power of the experimental control. So now, strong, right? Here we go. Those are the variables that determine the extent to which you could argue that a study, not a basic effect, a study demonstrates strong experimental control. Moderate experimental control, you've got all of those, but you don't quite have enough data points. you're basing it on 3 or 4 data points rather than 5. You've got 3 demonstrations, but you actually had 7 kids. 5 of them demonstrated the effect and 2 didn't. So you've got some demonstrations that were not there. Or you're using a non-concurrent multiple baseline, right? Now, 78% of you emitted recognition eye contact when we talked about non-concurrent versus concurrent baselines. So one of the things we're going to have 15-second digression so that we're all on base with concurrent versus non-concurrent. So multiple baseline. In a multiple baseline, I want you to look at study one over there. So you see 3 students, each has a baseline, each has an intervention. But look carefully. The baselines are exactly the same. So this is a concurrent study in which everybody got baseline and then